Hi, welcome to the Dots and Boxes implementation by Matt Jacobs. Let's run the code. Save. Okay, so number of rows, let's do 2. Number of columns, 1. Number of collies, 3. Beta pruning. Let's do Y for yes. You can do N for no. I'm going to do row 0, column 1. The AI then chose row 1, column 0. I'm just going to do 2, 1. Oh, yeah, I got it. I'm going to do 3, 1. Oh, 3, 0, sorry. And then I will do 4, 1. Here we go. So I got this one for 2 points. AI got this one for 5 points. AI player is the winner. Again, score 2 to 5, game over. Okay, so let's go straight to the AI logic. So when it's the AI's turn, it will run through here. We give the AI the current node, which has the current game state. Then, if we do alpha beta pruning, we choose this function with alpha beta pruning. Else, if no alpha beta pruning, we then choose this value function. Once we have the value, we will then iterate through all of the children. Whichever child has the same value as the given node value, then that's the child that we chose. So we choose that child and output the choice here. Lots of great notes here for how it works specifically. Without alpha beta pruning, we go to this function. If base case of max depth or leaf node, human points minus AI points, return node value. Also, we make children. Have a by function here. Max if we are the human, or min if we're the AI. Set the current value to be the player's default starting value. For each child, we want to find the value of it recursively, and then set this node value to the compare of the current value to the child value. The compare is min or max, depending on which player we are. Then return that value. If we do have alpha beta pruning, the difference is that here, in the base case, if we're the human player, we then want to update our alpha value with the between the max of the node value and alpha value. And if we're the beta, if we're AI, then we want to update our beta value to be the min of the node value and beta value. Else it's the same as before. Here, if it's not base case, make children, just like before. If we're the human player, we want to set to a small default value, else we're the AI, so high default value. For each child, we want to give the child the current alpha beta values, then recursively solve for the child's value. If we're the human, then we want to update our node value to be the max of the child value and the node value. And then we also want to update our alpha value to be the max of the alpha value and node value. We do the same for beta, but it's going to be the min if we're the AI. For pruning, if alpha is greater than or equal to beta, we just break, and then we return the current node value. Here we make children. This just aggregates the children. This creates the individual child nodes based off the parent node's information. Lots of great information. At the very bottom, we're going to have the node data structure, and it just has points. The game board actually holds the points, but when we give the AI the current state, we want the AI to have a copy of it as well. So the node has the AI copy, basically, of points and depth, who the current player is. The node is the AI's copy of the current game state, basically. The game state is represented as a string of 1s and 0s. 1 if it's chosen, if a side is chosen. 0 if it's not. If it's a 0, we can make a child, basically. The game board, we have a boxed class. So let's go to the game board. And then what we basically do is the board itself is a matrix. And we first want to go through the matrix and instantiate all of the classes in each of their appropriate tiles. We then want to, once we've done that, we want to set references for each of them to each other. We then display the board here. So this function can display it for the user. Choose. Once a player's made a choice, they choose, they give it here, and we will update the game board accordingly. Each of the 3 classes is a tile. And the tile just has a to-string method, which makes printing easier. The box is right here. The box basically has the winner, and it references 4 sides as well. It has a number of points. The side data structure is here, and it basically is just this. It could be horizontal, vertical or horizontal, and it references up to 2 boxes. Here's the state machine. It goes between human and AI. And the assignment 2 sets up the game board. Thank you.